Alright, this time we're looking at solving equations by graphing. And if you go back to solutions before, we're saying, alright, we want to take and write our equation y equals a squared plus bx plus c, and the solution is going to be what number can you put in for both of those x values that give you a y value of c, or essentially what are the x-intercepts, what are the x values that have a height of 0. So the solution equals the x-intercepts of the parabola. So if you're looking at that with a graphing calculator, so you could just graph on your graphing calculator and trace it. So hit that trace button after you hit graph and then figure out what are the x values for a y value of 0. If you want to get better accuracy, zoom in. So zoom in for better accuracy. I'm kind of going under the assumption that you know how to zoom in, and then you remember that when you're done you press zoom and then hit number 6 to get back to that standard window. If you need help with that, ask in class, or I suppose you could just search it on YouTube. You can find it that way too. The other way that you could do it, or a way that you could check your answers, is once you find out certain numbers work for x, you could check in the original equation. So take that 1x value or those 2x values, put them in for x in the equation, see does it equal 0. Another way you could do it is check the table on your calculator. That works really well. That's slick as long as you have integer x values. It doesn't work as well for finding it if the x-intercepts are like 4.2 or 8.7 or something like that. You can, though, change the delta x, that the default is set that it's the x values are going to go up by 1. But if you look at the top of your graphing calculator, I believe it's second and then the window, up above that there will be like a delta TBL, or actually I think it's TBL set. I think it says if you pick that, then you can change this delta x or delta table to, instead of going up by 1, it goes up by 0.1 or something like that. I can show you that in class too if you really want to see. But all right, let's say we want to do this. So first of all, if we want to find the solution to this, that original equation is really starting out kind of in the form of y equals 2x squared, which happens to equal 18. So if we want to solve this, if we want to find x, our first step is really we need to make this thing equal 0 instead of equaling 18. So we do that by subtracting 18 from both sides. And that gives us 2x squared minus 18 equals 0. Or essentially y equals that. So we're trying to figure out where does y equal 0. Alright, so if you have a graphing calculator then, you could take and punch this thing in. It'll look similar on a graphing calculator to this, but you look at that and see, ooh, it looks like it nicely has x-intercepts of -3 and 3. And you could zoom in and trace, or since they look like they're integers, I'd probably just use the table function. But then for that, for a final answer, what you may want to write is something like -3. You could write and 3, or you could do like comma 3 and then put it in the curly brackets. So it's saying the set of numbers, the set whose members are -3 and 3. You just can't do the normal parentheses because that would say it's a point, and it's not a point. Alright, so that's the one. Alright, this next one, find the solution of 2x squared plus 4x equals -3. Well, I'd start and say, well, if we do that there, we get 2x squared plus 4x plus 3. And we're really punching in a calculator using that, but we're trying to figure out where does that equal 0. And if we take and punch that into a calculator, your graph will look like this new one, and looking at that, there are no x-intercepts. The whole thing is all up above the x-axis. So for one like this, probably best to write no solution. So no solution. Alright, one last example and we are done. So a frog's jump height is given by this equation here. How long is the frog in the air? Well, if you take and punch that equation in, just going to show what will appear on the screen here. So your calculator will look something like that. Now, really you need to zoom in because it's the point you're looking for is kind of like over here. And so to see what's going on, best to do like zoom, and then you could go and draw a box around it. So do that zoom box. Or you could just click zoom in instead and maybe move your cursor kind of right about there and then hit enter a few times. But essentially when you zoom in, you'll get something that looks like this here. And as you zoom in further and further and further, you can tell that, well, it's your hash mark on your graphing calculator is going to say 1 is right there. So your best bet probably be to, once you zoom in, go and trace. And then if you move your cursor over to that point there, it's going to tell you that the x is 0.75 when the y value is 0. So how long is a frog in the air? Well, he takes off right here, and then he goes up and comes back down, 0.75. If you don't want to use it with your calculator, you could go back rocket old school. Because he has a height of 0, figure out what this is using negative b over 2a, and then double it. But I digress. That's it for this section. Like I said before, if you're struggling with some of the calculator stuff, hit me up in class, or you could search for things on YouTube. That's all I got. Have a great day.